Our today's topic of discussion is combining events in probability. By the end of this section, we will be able to understand how to combine events using complement, union, and intersection, three basic characteristics of set theoretic algebra, apply the addition rule to the events in general and mutually exclusive events in particular. So the probability for complements. First, we will describe what is the complement of a set. If A is a set, then A complement, writing A to the power C, or A bar or A prime is read as A complement. And it means set of everything outside A. So if you look at the picture, if A is the set, which is described by this oval diagram, then everything outside the blue shade of this oval diagram is a complement. The rules for probability that associates an event with its complement is pretty nice. It says probability of the event A plus probability of the complement of the event A is equal to 1, which then gives rise to a bunch of different formulas. For a fact, you can subtract probability of A complement from both sides, and you get probability of A equal to 1 minus probability of A complement, or you can subtract probability of A from both sides and you get probability of A complement equal to 1 minus probability of A. And I kind of have showed you why this result is going to be true as a very informal proof. There are two other major set theoretic concepts that we're going to learn. One is intersection and the other is union. The intersection of two events or two sets is the overlap between the two sets. So if I look at the diagram on the left, if the first circle on the left is A and the other circle on the right is B, then their intersection is where the two circles overlap. So what is intersection? For two events A and B, I write A upside down U, B, and read it as intersection. And this is overlap or whatever is common in both A and B. So overlap of A and B. The union, whereas, is if you are either in A, so either you are in this portion, or you are in B, so or you are in this portion, or you are in the overlap of both of them, so you are in both A and B, then you will be called in the union. So I write a big cup, B, so that is read as A union B, and that is everything that is either in A or in B. So the probability formula is called the inclusion-exclusion formula or the addition rule, and it says probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Whereas if I include one more set, so probability of A union B union C is probability of A plus probability of B plus probability of C minus the probability of the intersection minus the probability of the intersection of B and C minus the probability of the intersection of C and A and plus the probability of the intersection A, B, and C. This formula is called the inclusion-exclusion principle. Now we are, as usual, not going to be very hardcore learner of the formulas and understanding the math behind it. We are going to remember the addition rule, especially for two events. And all I want to remember is that probability of A union B is equal to probability of A plus probability of B minus probability of the intersection of these two events. Two events are going to be called mutually exclusive or disjoint if they have no outcomes in common. We'll remember these two terms. Mutually exclusive or disjoint if there is no overlap between them. So in this situation, the addition rule is a little different. as you can imagine. So in this situation, I mean, I should not say the addition rule is different. Probability of A union B, remember the formula says it is probability of A plus probability of B minus probability of A intersection B. But because there is nothing in the intersection, as they are mutually exclusive, then I get to say this is probability of A plus probability of B, as there is nothing in probability of A intersection B, so that is 0. So the addition rule becomes probability of A union B equal to probability of A plus probability of B. So let's do a couple of exercises. The game of Monopoly. You are playing Monopoly with your roommate. The loser does the laundry for both for the rest of the semester. Your piece is sitting on the waterworks and you are about to roll your 2 fair dice. Your opponent has hotels on Park Place and Boardwalk, and if you land on either one of those, you will lose. Park Place lies 9 spaces and Boardwalk lies 11 spaces away. So I need 2 different events. Park Places, I'm going to call PP, and I will call it Park Places. And the other event, of course, is going to be Boardwalk. So that I don't have to use these long words, I'm just going to abbreviate them as my events. So the first question being asked is, what is the probability that you will land on Park Places and get stuck with the laundry duty? So the question is probability of Park Places. Well, you will land on Park Places if you roll the 2 dice and the sum is a 9. So let's write down what are the possibilities to get the sum of 9 in rolling 2 dice. So Park Places, this event is going to be, you can get 3 and 6 giving you a 9, 4 and 5 giving you a 9, 5 and 4 giving you a 9, and 6 and 3 giving you a 9. And I believe these are the all. So there are only 4 of them. So it's 4 over 36. So that's the probability. Or you can say 1 over 9, whichever way you want to write it. 1 over 9, which is 0.1111, rounded to 4 decimal places. Answers my question. The second one is, what is the probability that you will land on Boardwalk and still get stuck with the laundry duty? So I want to know probability of Boardwalk. And remember, this one, you will land there if your sum is 11. So I will write down what are the dice possibilities. I must get 5 and 6, or 6 and 5, and then the sum is 11. So there are only 2. So I'll say this is 2 over 36, and that is 1 over 18, which is equal to 0.05, and so on and so on. In fact, it should be, I should check that in my calculator. So I had 0.1111, and I should get 0.0 and then all 5s. So 0.0556, rounded to 2 decimal places. Then the third question is, what is the probability that you're going to lose the game? Remember, you're going to lose the game if you land on either Park Places or Boardwalk. So I said either Park Places or Boardwalk. How do I write it in probability notation? It is probability of Park Places or, so union, Boardwalk. And that basically has done the problem for you. So this is by the formula of addition, probability of Park Places plus probability of Boardwalk minus probability of Park Places intersected with Boardwalk. That's just the formula of addition. Now recall one thing. In a single move, you cannot get a sum of 9 and 11 at the same time. So you cannot be at both Park Places and Boardwalk at the same time. So the intersection, Park Places and Boardwalk, is nothing. There is nothing. It is not possible. So the probability is going to be 0 there. So I will say that it's the probability of Park Places, which I found to be 4 over 36, plus probability of Boardwalk is 2 over 36. So I get 6 over 36, which is 1 over 6 when simplified, and then I can write it as 0.6 So 1, 6, 6, 7 rounded to 4 decimal places answers my question. Since probability of Park Places intersected with Boardwalk is 0, this event will not have any outcome in it. It is not feasibly possible to be in Park Places and Boardwalk at the same time. The other side of the game, as well as the condition in the last exercise, you have hotels in green properties, Pacific, North Carolina and Pennsylvania avenues. So, and if your roommate lands on one of them, your roommate will be sorting your laundry starting tonight. Your roommate's piece is on B&O Railroad. What is the probability that your roommate will be on Pacific Avenue 6 spaces away? And what is the probability that your roommate will be on North Carolina Avenue 7 spaces away? And what is the probability that your roommate will be on Pennsylvania Avenue 9 spaces away? So I'm going to first abbreviate them. So Pacific Avenue, let's call it PC. And I'm going to call it Pacific Avenue. And then North Carolina Avenue, let's call it NA. And as I have said earlier, these are your choices. No one is going to tell you. Once you have selected these abbreviations, write it and do whichever way you want to. And finally, you have Pennsylvania Avenue. I will call it PN. So that will be, for me, this is the Pennsylvania Avenue. And let's find out the probabilities. So first one, probability of Pacific Avenue. And this is 6 spaces away, and so I need a sum of 6. So the way I can get them is I can get 1 and 5, I can get 2 and 4, and I can get 3 and 3, I can get 4 and 2, I can get 5 and 1, and that's it. So how many total options I have? I have 5 total options, so the probability is going to be 5 over 36. So let's keep it in this form. The second one is, what is the probability that your friend will land on North Carolina Avenue? So probability of North Carolina Avenue. Now remember, North Carolina Avenue is going to be the event with the outcomes that will give you the sum of 7. And 7 can happen as you have the hand 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. And that's it. So this time you have 1, 2, 3, 4, 5, 6. So probability of North Carolina Avenue is going to be 6 over 36, which I can write as 1 over 6. And finally, I want to find the probability that your friend is going to land on Pennsylvania Avenue. So probability, this is my notation for Pennsylvania Avenue. In Pennsylvania Avenue, as per the problem, is 9 spaces away, and the way to get a 9 as a sum, you will expect to get a 4 and 5, or 5 and 4, a 3 and 6, and a 6 and 3. So there are 4 of them, so this probability is 4 over 36. Someone can say that this is 1 over 9. And finally, I want to know, what is the probability that your roommate will lose the game on this roll? So losing for your friend. Probability of losing will happen if your friend arrives on North Carolina Avenue, or, so Union, Pacific Avenue, so PC, or on Pennsylvania Avenue. Remember, the inclusion-exclusion formula will tell you probability of North Carolina Avenue plus probability of Pennsylvania Avenue plus probability of Pacific Avenue minus probability of the intersection of 2 of them. But again, think about this. All the intersection, doesn't matter whether I'm doing the intersection of 2 of them or 3 of them, are not possible. You cannot be in more than one square at the same turn. You cannot have 2 different sums in the same hand. So I can skip the rest of the inclusion-exclusion principle, the addition rule, and just find the sum of these 3 probabilities. So probability of NA is 6 over 36 probability of PN, Pennsylvania Avenue, is 4 over 36, and probability of Pacific Avenue is 5 over 36. So I'm going to add them. 5 plus 4 is 9 plus 6 is 15. So it's 15 over 36. Then I can divide both top and bottom by 3 and I get 5 over 12. And then I can simplify this number in my calculator to know the probability in decimal format. Don't forget to round to 4 decimal places. So this is going to be 0.4167, and that answers my question. We'll do more examples of inclusion, exclusion principle and complementation in our next video.